All right, now we've come to part 2, the revenge. It's always the revenge when it comes to in movies. So what we're going to first look at is electron affinity. Electron affinity is the energy released by gaining an electron. So it's kind of like the opposite of ionization energy. So this is going to release, not need energy, in order to gain, not lose an electron. So the period trend, it becomes more negative. So the number gets larger, but these are all negative values. So it becomes more negative. Why? Well, with atoms getting smaller, this increases the pull of electrons and releases more energy because they're all more attracted. So with atoms getting smaller, this increases the pull of electrons and releases more energy because they're all more attracted. Going down the group, this will become less negative. So the number will get smaller. They're all negative, remember. But it will become less negative. Why? With atoms being larger down the group, less energy is released because of their lower attraction to those electrons. So with going down, the group has less energy because less energy is released because of the lower attraction to those electrons. All right, well, next we're looking at electronegativity. I like to think of this as the money trend because understanding this will help you understand a lot of chemistry. So this is the scale of how an atom attracts electrons of another atom. Going across, so this will increase going across the periodic table. Why? Since the atoms are smaller, the attractive nucleus is closer to the outer electrons, increasing the ability to attract other electrons. Likewise, size matters on this one, going down. Going down, the group trend decreases. Atoms get larger, so the attractive nucleus is further from the valence electrons, decreasing the ability to attract other electrons. That is the Y. All of it goes back to size. So as you can see, these get smaller, and look what happens to the electronegativities. They get larger, pretty much. Okay, so this is how it's related to size. Coming down to the end, we have metals and nonmetals. As you can see, most of the periodic table to the left side are metals, and the trend here is as you go across, the reactivity of metals, which means losing electrons, is going to decrease. Why? Atoms get smaller, the electrons get closer, so it's harder to lose an electron because it's stronger attraction. Going down, it's going to increase reactivity. So going from lithium to cesium, the reactivity is going to increase. Why? Atoms get larger, so the electrons are further from the nucleus. Therefore, it takes less energy to lose those electrons and become a reaction. Now, nonmetals are a little different. Nonmetals, we only have a very small cluster in the upper right that are reactive. Metalloids often act like nonmetals, so we can consider this little cluster all to be nonmetals. They want to gain electrons. So going across the period, they're going to increase. Why? Since the atoms are smaller, the electronegativity is higher, making it easier to get other electrons and react. So remember that again, this is tied to electronegativity, not electron affinity. Going down, this trend will decrease reactivity. These become larger, the electronegativity becomes lower, therefore making it harder to attract electrons and therefore react. The trends of electron affinity, ionization energy, atomic radius, and electronegativity increasing and decreasing are on your reference sheet for your periodic table. Reactivity is not, so you need to understand it. Nonmetals connect to electronegativity, while metals go for ionization energy. So we have our last final thoughts, our joke. What do you call a joke based off cobalt, radon, and yttrium? You call it corny. Answer the final question and let me know what questions you have in class. See you soon.